Let us learn about the fourth property of skew-symmetric matrices. Okay, so the fourth property says something like this. This is fourth property. If A and B are two symmetric matrices, A and B are two symmetric matrices of same order. Okay, of same order, then λ₁A plus minus λ₂B is also skew-symmetric matrix for scalars λ₁ and λ₂. For scalars λ₁ and λ₂. So let us have a look at this particular thing. So A and B are two skew-symmetric matrices. So it clearly means that as A and B are two skew-symmetric matrices. Now why are they of the same order? Okay, they are of the same order because addition will be defined only when they are of the same order. This particular addition will be defined only if A and B have the same order. If A and B don't have the same order, then this addition or subtraction will not be defined. Okay, so that's why A and B must be of the same order. And they are what? They are skew-symmetric also. Okay, they are skew-symmetric and they are of the same order. Then we have to prove that λ₁A plus minus λ₂B, λ₁A plus minus λ₂B is also skew-symmetric matrix for scalars λ₁ and λ₂. Now λ₁ and λ₂ are scalars. What does it mean by scalar? Scalar means constants. Scalars means constants. So λ₁ and λ₂ are constants over here. Okay, and we have to prove that this particular expression is also skew-symmetric matrix. So let us start the proof. Before starting any proof, we need to give the information. We need to give the information which has been provided to us, and we need to then move further. Okay, so let's write the information given first. So A and B are two skew-symmetric matrices already given to us. This is given information, right? This is what? This is given information. This is given information that A and B are two skew-symmetric matrices. So obviously A transpose will be equal to minus A and B transpose will be equal to minus B, because A and B are skew-symmetric. So by definition of skew-symmetric matrices, A transpose will be equal to minus A and B transpose will be equal to minus B by the definition of skew-symmetric matrices. Okay, A transpose is equal to minus A and B transpose is equal to minus B. Let us assume that this is equation number 1. Let us assume that this is equation number 1. Let us assume. Okay, now λ₁A plus minus λ₂B complete transpose. Okay, λ₁A plus minus λ₂B complete transpose is equal to what? Is equal to this. Now in the bracket you must write property. In the bracket property must be written like this. Okay, as A plus minus B complete transpose is equal to what? Is equal to A transpose plus minus B transpose. A plus B complete transpose, A plus B complete transpose is equal to A transpose, okay, plus minus B transpose. So this is the thing which you have learned. Let me write it properly. I don't know what happened to it. Okay, now it is looking good. So A plus minus B complete transpose is equal to A transpose plus minus B transpose. Okay, now this is the property which has been used over here in this first step. This is like A and this is like B, although lambda is additional over here. So A plus minus B complete transpose is equal to A transpose plus minus B transpose, just like this property. Now we already know that. What do we know? We already know that lambda times C complete transpose is equal to what? It is equal to lambda times of C transpose. Okay, so the constant can be taken out of the transpose operation. Okay, the constant can be taken out of the transpose operation. So lambda times of C complete transpose, lambda times of C complete transpose is equal to lambda times of C transpose. Okay, lambda times of C complete transpose is equal to lambda times of C transpose. Okay, so λ₁A complete transpose is equal to λ₁A transpose. Lambda can be taken out by this property. By using this property, you must write it in bracket. Okay, λ₁A complete transpose is equal to λ₁A transpose plus minus as it is. λ₂B complete transpose is equal to λ₂B transpose. Okay, this is the thing, by this property, by using this property. Now A transpose, as A is a skew-symmetric matrix, so A transpose is equal to minus A. So A transpose can be replaced by minus A, and B transpose can be replaced by minus B, because A and B are skew-symmetric matrices. So B transpose is replaced by minus B. Okay, now in this expression, in this particular expression, Okay, in this particular expression, you can take minus sign common out of this. Okay, you can take minus sign common. Okay, from here minus sign and from here minus sign, it can be taken outside common. So minus sign has been taken out common outside. Okay, minus sign has been taken out common outside. So minus sign is over here, and the rest of the expression lambda 1a, lambda 1a, lambda 1a, so lambda 1a plus minus, so plus minus, lambda 2b, so lambda 2b. Okay, now have a look at this particular expression. Now let us assume that this complete expression is a matrix C, and if that is matrix C, then this particular expression will also be matrix C. This particular expression will also be matrix C. So clearly C transpose is coming out to be equal to minus C. Okay, so therefore C is skew-symmetric. Therefore C is skew-symmetric, as C transpose is equal to minus C. That's why C is skew-symmetric. So similarly, in the place of C we can write this. So this is skew-symmetric. This particular expression is skew-symmetric because it has come out to be equal to, when we took its transpose, it came out to be minus multiplied by that matrix. When we took the transpose of that matrix, it came out to be equal to minus times of that matrix. Okay, so this is the thing. So lambda 1a plus minus lambda 2b, lambda 1a plus minus lambda 2b is also skew-symmetric matrix. Okay, so lambda 1a plus minus lambda 2b is also a skew-symmetric matrix. This has been successfully proved in this particular class. Okay, now from the property 5th onwards we will learn in the next class. From property 5th onwards we will learn in the next class. Till then, take care of yourself and please like, subscribe and share. From the 5th property onwards we will study in the next class.